Okay, practice exam 2. There are 20 questions in this assignment. So first question, find the slope of function's graph at the given point. Then find an equation for the line tangent to the graph there. So we have given a function here, f of x, and we would like to find, slope of this function at point -3, 9. So, your function could look like this, and there is a point -3, 9. At this point, if you draw a tangent line like this, then we would like to find out the slope of this tangent line. So remember, the slope of tangent line means we are trying to find derivative of this function at that point. So the idea is we need to find out the derivative, and we need to find out the value of that derivative at -3. That would be the slope. And for finding the equation of tangent line, equation of any line can be found by using this formula, which is y minus y1 equal m times x minus x1, which is also called point slope form. So if you know the slope, which can be found by this, and then point x1 y1 is already given here, -3, 9. So we're going to do this here. So let's try to find out the derivative of this function f prime of x. As you can see that by using the power rule, this would be 2 times 2 times x, which is 4 times x. The derivative of 3x is 3. And since the slope is the value of this derivative at -3, so just plug x equal to -3 here, which is 4 times -3 is -12 plus 3 and -9. So slope of the tangent line is equal to -9 at this point, -3. Okay. And now to find out the equation of the tangent line, this is the equation we're going to use. So equation of the line is y minus y1 equal m times x minus x1. And for x1 and y1, we already have given this point -3, 9. And slope we found -9. So we're going to plug that value back here. Y1 is 9, x1 is -3, slope m is -9. And because of this negative and this negative becomes positive, and we can distribute this -9 here. So it will be -9 times x is -9x, -9 times positive 3 is -27, and we can bring this -9 to the right side by adding 9 both sides, and by doing that there will be plus 9 here. So this is the equation of tangent line at the point -3, 9. Okay, so these are the answer. Let's go to the next problem. Find the point at which the graph has a horizontal tangent line. So we have a graph. Horizontal tangent line means line should be horizontal line, and we know that horizontal tangent line has a slope 0. So we are looking for points on the graph such that the slope of that curve at that point should be 0. So how we're going to solve it? We have given a function y. We try to find out y prime, which is derivative of this function. After that, we equate this derivative with 0 and solve for x. Solve for x, and that will give you a point where we have horizontal tangent line. So y is 3x squared plus 8x minus 8, and y prime, just to use the power rule here. By using power rule, the derivative of the first term is 3 times 2, which is 6, x plus derivative of second term is 8, and the last term is 0. So now, because we are looking for the horizontal tangent line, this slope should be 0, and that means 6x plus 8 should be 0. And by solving to solve for x, we just have to bring this 8 to the right side and then divide both sides by 6. So eventually this is a point where the slope of the tangent line on this graph is 0. So that is the point x equal -4/3. That is just the x coordinate of the point. We need x coordinate and y coordinate both. For finding the y coordinate, after finding the x coordinate, we are going to put this x back in the given function here. Okay, back in the given function here. So which is y equal 3x squared plus 8x minus 8. So I'm going to put x equal -4/3 here and do the simple calculation. and then eventually after simplification I'm going to get negative 40 over 3. You can simplify this thing by making the same denominator. That's the one way. uh, so here is a 9, here is a 3, and here is a 1. So you can just multiply this term by 3 and 3, and here 9 by 9, and now we have all the terms have 9 on the denominator, and then just do the simplification on the numerator, and then this will be the answer. So the point where the function has a horizontal tangent line is actually negative 4 over 3 comma negative 40 over 3. We have given a function 2x plus 5 over x, and we need to find out the derivative. We can just use the power rule. Power rule means if you have x to the power n, then derivative of x to the power n is n times x to the power n minus 1. And if we want to find out the derivative of 1 over x, we have to bring this x on the top, and that will be x to the power negative 1. And again we can use this power rule, and that will be negative 1 times x to the power negative 1 negative 1. By using this formula will be negative 1 over x squared. So that is the derivative of 1 over x. So by using this formula we can find the derivative of the first term, which is 2, and then derivative of 1 over x is negative 1 over x squared, and 5 is already there. So this is our answer. Okay, so a graph the derivative of the function graphed on the right. So this is the graph of the function, and we would like to plot the graph of derivative of this this graph. So one thing what we can do is, if you just zoom in this graph here, okay, if you just zoom in this graph, you can see that the derivative at this point, like here, 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 is the slope of the tangent line. And as you can see, the tangent lines are horizontal, so that means the slope of this curve at this point would be 0. So we have given 4 different options. So we are looking for 1, 2, 3, 4 different points on the graph to the left side of the origin, such that the value would be 0. So for this one we have 1, 2, 3 points only. So this is not the right one. Here we have just 1 point where the function is 0. Remember, we're trying to find out the graph of derivative of this curve. So we know that there will be 4 zeros on that graph to the left side of the origin. It has only 3, it has 1, it has 1, and then only possibility would be this one, the last one. 1 0, 2 0, 3 0, 4 0. So the correct choice would be this one. Okay. Okay, so now we have given y as a product of two different functions, two different values, and we need to find out the derivative of this product, and we are going to use product rule here. Let's assume that the first part is u and second part is v, like this. And since we we would like to use the product rule, excuse me. So the product rule is if you product rule is if you have two different function u and v, and you want to find out the derivative of the product, it is actually derivative of, you can keep the first one function and derivative of the second function, plus you can find the derivative of this first function and just leave the second function. So here the first function is u, the second function is v. Find out the derivative of u by using the power rule, and that is 16x. And then find out the derivative of v. The derivative of x is 1, and the derivative of 4 is 0, and derivative of 7 over x is negative 7 over x squared. So we're going to plug u prime, v prime, u and v in this formula, and that will give us the derivative of this product. U is already given, so we just have to put v prime here and u prime here. So v prime goes here and u prime goes here. And now second part, we would like to multiply them first before finding the derivative of those product without using the product rule. So let's find out the product of these two functions, these two value u and v. For that we can use we can just FOIL them. So you just have to multiply 8x squared with first, second and third term. And that will give you this, this and this. And now you have to do the same thing. 3 times x, 3x, 3 times 4, 12, 3 times 7, 21 over x. So this is the product. But we can simplify this by combining the like terms like 56x and then 3x. And that will be 8x cubed, 32x squared, 56 plus 3 is 59, 12 plus 21 over x. Now we would like to find out the derivative of each of them, which is by just using the power rule. So it will be 8 times 3 is 24 x squared, 32 times 2 is 64x, the derivative of 59x is just 59, derivative of 12 is 0, and derivative of 1 over x is negative 1 over x squared, and there is a 21. So that is the answer for the second part. So here we are going to use a quotient rule. So let's assume that the function on the top is u and then the value on the bottom is v, and this is the quotient rule. To find out the derivative of this kind of quotient, you can use this rule, and the rule is u times v prime minus u prime times v. Okay, did I do something wrong here? Okay, 40 square minus 9. Okay, it should be opposite. Okay, it should be u prime times b and u times b prime. So u prime is 18t plus 5. Okay, I just did opposite here, so you just have to switch it, and then eventually the answer would be negative of this. Eventually the answer would be negative of this. Okay, so the formula should be it's not the right formula here. It should be u prime times v minus u times v prime. So this is u prime, this is u, this is v, and this is v prime. Plug this value back in this formula, just switch them. I just did some mistake here while I was doing this problem. The mistake is I just switched the order. So just switch them and then do the simplification, and then cancel the these terms like these terms, and then simplify it, and eventually you are going to get the answer. Your answer would be a little bit different than my answer here because you have to switch the order here. Okay, I'll just let you do this because you know how to switch them. The value is already here, and how to simplify them. Okay, so this is another question number 7. Find the value of a. Here is a. G of x is piecewise function. G of x equal ax for all x less than 0, and g of x is x squared minus 3x if x is greater or equal to 0. We need to find out the value of a such that this function g of x would be differentiable. So to solve this problem, first of all, understand that there is a meaning of differentiability. There is a definition. A function g of x is differentiable, and this is the definition, if this limit exists. Okay, and at this point we would like to just find out either this function is differentiable at 0, and since we know that this is differentiable at 0, so we just have to replace this x by 0 here. So this function would be differentiable everywhere, especially at 0, because on the left side of 0 it's already differentiable because it's a linear function. On the right side of the 0 it's already differentiable because it's a polynomial function. But at 0, to be differentiable, this limit should exist, and the limit does exist if the left hand limit when h approaches to 0 and right hand limit when h approaches to 0 are same, meaning this limit exists if this value and this value, both of them are same. And now as you can see here, when h approaches to 0, we're going to use the function this one, a times x, and when h approaches to 0 from the right side, we are going to use the value of the g of x from here, the second part. So g of x is given, which is ax when x is less than 0. So that would be g of h, which is a times h, because g of x is a times x, so g of h would be a times h. G of 0 is, no matter, if you want to find out g of 0 by using this function a times x, it would be 0. So it will be a times h over h, and after cancellation this h and this h, and after taking the limit would be a from the left side. From the right side, we're going to do the same thing. We have given g of x is x squared minus 3x. We're going to replace this x by h for the first part, which is h squared minus 3h. For the second part, we're going to replace this x by 0, and it would be 0. After simplification means if you factor out h on the top, it will be h minus 3, and h on the bottom, you can cancel this h and this h. Finally, if we take the limit of h minus 3 when h approaches to 0 from right side, it would be negative 3. So to the function g of x would be differentiable if this value, this limit from the left side and this limit from the right side, they are equal. As you can see that the left hand limit is a and then right hand limit is negative 3. So the value of a should be negative 3 to be this function g of x differentiable. Okay, so the value of a is negative 3. Okay, so there are three different parts here in this problem. The first one, as you can see, a body moves on a coordinate line such that it has a position. This is the position function. Let's make it zoom in here. This is the position function, and then body is moving when the time interval is from 1 to 2, and you can see that this position is the unit of this position is meter, and the time is in second. Now these are the questions we have to answer. The first one is find the body's displacement and then average velocity for the given time interval. Find the body's speed and acceleration at the endpoints of the interval. And when, if ever, during the interval does the body change direction. So these are the three parts of the question here. First of all, displacement means it's the position, the difference between the position of this this body. So this is actually the value of function at 2 minus the value of the function at 1. In this case, either you can use f of t or s, so that's the same thing. Average velocity means it's a displacement over time. In our case, it's f of 2 minus f of 1 over 2 minus 1, because that's the time interval we have given. Speed is actually its absolute value of the velocity, and we can find the velocity by finding the derivative of the function we have given, the position function. Acceleration means it's a second derivative of that position function. And then finally, to answer this part C, when, if ever, during the interval does the body change direction. So to answer this question, you have to understand velocity has sign. Velocity could be positive or negative. Positive or negative. This positive and negative velocity tells you the direction of object. Let's say the velocity is positive, then you might say that the object is moving to this direction. And let's say that when the velocity is negative, the object is moving to the opposite direction. So to check either object is changing the direction or not, you just have to find out either there are positive and negative velocity, both or not, and that can be found by looking at the velocity function. Okay, so these are the three different you know uh, question we're going to answer by using this relation here. So the first of all, to find out the displacement, the position function is given, which is 4 over t square minus 2 over t. We can find the value of this position function at 1 and 2 by plugging t equal 1 here, which is 4 minus 2, and which is equal to 2, and 2 here, which is 0. So the displacement is s of 2 minus s of 1, or f of 2 minus f of 1, that's the same thing. Just plug the value of s of 2, which is 0, and s of 1, which is 2. So displacement is negative 2. Now the average velocity can be found by using this formula, displacement over time interval, and displacement is negative 2 here. The time interval is 2 minus 1, because the body is moving from 1 second to 2 second interval. So this is the average velocity. For finding the second thing, which is velocity, we need to find out the derivative of the function here we have given by using power rule. So the derivative of the first part, as you can see, is negative 4 times 2 over t cubed. Just use the power rule. This derivative for the second part is positive. This negative becomes positive because we know that the derivative of 1 over t is negative 1 over t squared. So that negative and this negative becomes positive 2 over t squared. So this is the velocity. We want to find out the velocity at the the speed at the end point. So we know that speed means the absolute value of the velocity, and end point means there are two endpoints: the left end point, which is when time is 1, and then right end point when the time is 2. So we need to find out the absolute value of this velocity when t is 1, which is just replace this t by 1 here, and that will be 6. And right end point means just replace this t by 2 and find out the absolute value, which will be half. Okay, so these are the speed at the end points. Finally, we know that velocity is this one, and we can check the value of the velocity at endpoints, which is at 1 is negative 6, and at 2 is negative half. So at both endpoints the velocity is negative, negative, negative. So now we have to find out if there is any way this velocity goes here and becomes the 0, and then because if the velocity is so we know that the velocity to check either the velocity changes the direction or not, or the body changes the direction or not, we need to check either the velocity will go from negative to positive or not. That's only possible if at some point the velocity will be 0. So because to go from negative to positive, it has to cross this line where the velocity would be 0 if it's possible. So what we do, we just equate this velocity with 0 and try to solve for time. And when we do that, here we see that the time is 4. Only at 4 seconds this velocity will be 0. So in between 1 to 2 second, velocity is never 0. So velocity is all the time negative from 1 second to 2 second. So that means this body never changes the direction. Okay, so that means the body never changes the direction. So the answer is no change in direction. Okay, so the next question is very similar. An object is dropped from a tower which is 177 feet above the ground. The object's height above the ground t second into the falls is, this is the height function, and we need to answer these three parts. The first part is find the velocity, speed, and acceleration, and these are the formula. Velocity means just find the derivative of this position function, height function. Speed means the absolute value of the velocity. Acceleration means it's the derivative of the velocity, or double second derivative of this position function. So the velocity we can find out, it's just a derivative. Velocity is so what's the velocity? The velocity is the derivative of this position function, which is derivative of 177 is 0, and derivative of negative 16 2 square is negative 16 times 2t, so which is negative 32t. So that's the velocity. Okay, and for the speed, speed is as you can see that it's the absolute value of the velocity, which is absolute value of this one, which is non-negative number, which is 32 times t. And acceleration, at, is derivative of the velocity. If you try to find out the derivative of this function, it would be negative 32 only, because derivative of time t is 1, so it's negative 32. Okay, So the second question is about how long does it take the object to hit the ground, meaning what is the value of time when the position function, the height function is 0. So we need to solve this equation by equating 177 minus 16t square equals 0. Solve for t. So it's 16t square equal 177, and then just divide both sides by 16. So it's t square equal 177 divided by 16, and the time is square root of 177 divided by 16. So that's the time. One is positive value, one is negative value, but negative value doesn't matter to us because there is no negative time. So the only answer is square root of 177 over 16. Okay, that's the time when the position would be when the height would be 0, when the that object hits the ground. And then using this time, this is the time. At this time, what is the value of the function? That's what is the last question. What is the object velocity at the moment of impact? Meaning you throw something from this height, let's say some kind of ball, and it hits the ground after time square root of 177 over 16. We would like to find out what was the velocity of that object when the time is this. Okay, so the velocity, we already found the velocity. If the velocity is negative 32 times t, we just have to find out this velocity when time is square root of 177 over 16. 32 times square root of 177 over 16. We just have to find out this value. Okay, just use the calculator and find the value. And also don't forget to follow this instruction, round to the nearest tenth. Simplify your answer. Okay, so let's go to the next problem, question 10. We need to find out the derivative of trigonometric function, and there are two different trigonometric functions, so we have to use the product rule. But before that, we should know the derivative of secant function is secant x times 10x. Derivative of tangent x is secant square x, and this is the product rule. Just use these three formula and you will be fine. You will be able to find the answer. Okay. So the second question, so I just leave this thing to you because you already know the formula. Just plug the value of the derivative of secant x, the derivative of tangent x, secant x, and tangent x in this formula, then you will be fine. And this one, it's again derivative of trigonometric function. These are the formula you need to use. Derivative of cosine is negative sine x, derivative of sine is cosine x, and the quotient rule, this is the quotient rule. Now just plug the value of u prime v minus u times v prime over v square. In this case, u is 2 cosine x. So u is 2 cosine x, v is 1 minus sine x. So by using this formula, u prime is negative 2 sine x, and v prime is negative cosine x, because the derivative of 1 is 0 and derivative of sine x is cosine x. So just use u, v, u prime, v prime in this formula and you will be able to answer this question. This is the next question. It's a chain rule, or here you have given y equal some function to the power 5. So whenever you have y equal some function to the power, let's say n, and if you want to find out the derivative of that function, that's actually n times f of x to the power n minus 1 times the derivative of the function you have here inside this bracket. So in this problem, we want to write down this as y as a function of u and u as a function of x. So we need to find out which one is the true option. So I can write down y as a function of u like this, u to the power 5, where u is the function inside this parenthesis, which is x squared over 8 plus x plus 2 over x, and we just name this as g of x. So the right option, right answer, as you can see, is this one. Now we would like to use this formula we were talking here, this one, and find out the the derivative of this function. So the derivative of this function is 5 times u 5 times u to the power 4 times the derivative of u, which is derivative of this part, 2x over 8 plus derivative of 1 x is 1 minus the derivative of 1 over x is it's a negative 1 over x squared. So this is the answer. So implicit differentiation, we need to find out dy over dx. So problem question number 13 and 14 are very same questions. So to do this kind of problem, we always have to differentiate both sides of the equation with respect to x. And when differentiating both sides of the equation with respect to x, you have to keep in mind whenever we differentiate y to the power something with respect to x, this is actually n times y to the power n minus 1 times dy over dx. So this is the equation we have given, differentiate both sides with respect to x, and whenever you see x and y terms together, we have to use product rule, because x is the function, this is the function of x, this is also function of x. So when we use the product rule for the first term, the derivative of x squared is 2x, we just leave y as is, plus we leave 7x squared as is, and derivative of y is dy over dx. And again we need to use the product rule here. The derivative of x is 1, so the first term is 3y squared, plus the derivative of y squared is 2y times dy over dx. Our goal is to find dy over dx, so we just keep this terms with the dy over dx on the left side, and we bring this these two terms to the right side. And then after that we factor out dy over dx on the left side. So we factor out dy over dx from these two terms, and then we divide both sides by this thing. So on the top here you can see that the common factor is y, so I'm just factoring out negative y on the top, and on the bottom the common factor is x. So this is our final answer. For finding the derivative of function like this, we need to use this formula. If you are looking for the derivative of ln and some function of x inside the parenthesis, the derivative is actually 1 over whatever you have inside the parenthesis times the derivative of the function inside the parenthesis. So here you can see that in our case ln x to the power 8, so the derivative of this is, according to this formula, it's 1 over x to the power 8 times the derivative of x to the power 8 is 8 times x to the power 7. So it's eventually 8 over x, because you can cancel this x to the power 7 and x to the power 7 from the top and bottom. So this is our final answer. For finding the derivative of inverse function, we should know the formula. For this particular problem, the derivative of cosine inverse of u, where u is the function of x, is negative 1 over square root of 1 minus u squared times du over dx. So in our case, u is 3x to the power 5. So du over dx, which is derivative of this thing with respect to x, is 3 times 5 times x to the power 4, which is 15x to the power 4. If we use this formula here, the dy over dx would be negative 1 over 1 minus u square, which is in our case it's a 3x to the power 5 square, which is 9x to the power 10 times this 15x to the power 4. So that's our answer. Okay, so very similar question, but this time we are using quotient inverse of cotangent, cosecant, and that's the formula you are going to use. Very similar way, use u equal 4x squared plus 1. You plug the value of u here, you find the derivative of u with respect to x, which is 4 times 2 times x, which is 8x, and just use the formula and then just do exactly the way I did here, and you will have your answer. Problem 18. When a circular plate, we have a circular plate like this, of metal is heated in an oven, its radius increases. So whenever we heat metal, it always it expands. So that's the reason its radius increases, and the rate of increase of that radius is 0.02 centimeter per minute. At what rate is the plate's area increases when the radius is 44 centimeter? So to answer that question, we have to know for the circular plate, area is pi r square. That's the relation between area and radius. So write an equation relating to the area of the circular plate. So that's the answer. A equal pi r square. For the second part, we try to find out the derivative of a with respect to time, which is derivative of r square with respect to time, and by using the chain rule, this is 2 times r times dr over dt. So that's what you have to write down here. d over dt is 2 pi r times dr over dt. So it's a 2 pi r times dr over dt. So now we would like to find out the rate of change of area, which is this one. When the rate of change of radius is 0.02 centimeter. So this is just 2 pi, the radius at the beginning is 44 centimeters, so r is 44, and rate of change of radius is 0.02. Now just multiply this thing and that will be your answer. Here write down your answer in terms of pi. So if you multiply 2 times 44 times 0.02, which is eventually, I'm going to use my calculator here, it's 0.02 times 2 times 44, which is 1.76 pi. So that's our answer here, 1.76 pi. But remember, the radius changes centimeter per minute, but the area change would be a centimeter square per minute. Okay, because area means it's a square of the radius. So that's the answer. In this question, there is a ladder, 25 feet ladder like this, and leaning against a house. So this is the house, and when its base starts to slide away, by the time the base is 24 feet from the house, the base is moving away at the rate of 7 feet per second. What is the rate of change of the height of the top of the ladder? At what rate is the area of the triangle formed by ladder, wall, and then ground changing then? At what rate is the angle between the ladder and then ground changing then? So we have to use this figure, and we need to find out this three information here. Okay. Um, okay, to solve this problem, first of all, we are going to find out the relation between the variables here. So we know if you just zoom in this triangle here, you can see here, uh, this is the distance x, so x square plus y square equals 25 square. That's from Pythagorean theorem. So we have to answer this question when x value is 24 and rate of change of this x with respect to time is 7. That's the given here. We need to find out the value of y, which is the height of the ladder. By using this formula, it will be 25 square minus x square. So eventually it's a square root of 25 square minus 24 square, which is 7. So when the value of x is 24 and rate of change of this position of the the ladder is 7, then the value of y, which is the height of this ladder, is 7. And so these are the things we have to know. And to answer the question for the first part, what is the rate of change of the height of the top of the ladder? So we would like to find out what is dy over dt. For that, we're going to use this relation, this equation, and all this value. Okay. So if we differentiate this equation with respect to time, both side, we get 2x times dx over dt by using the chain rule, plus 2y times dy over dt for the second part, and then the derivative of the 25 is 0. And now because we want to find out dy over dt, so we bring this term to the right side and just divide both sides by 2y, and that 2 and this 2 will be cancelled out, and this will be our formula. So for finding the rate of change of y with respect to time when x is 24 and y is 7, and then rate of change of x with respect to time is 7, we just need to plug this value here. So we just need to plug x, y, and then dx over dt. That will give us negative 24. And that answer goes here, negative 24 feet per second. Remember, this negative means the value of x is, what is that? This negative means the value of y, which is the height of this ladder, is decreasing. It's going down. That's why this rate is negative here. Okay. That's the first part. The second part, the area is changing, so we need to find out the area because area is also changing. We know that area of a triangle is half times base times height. In our case, base is x and height is y. So for finding the rate of change of a with respect to time, we just need to find out the derivative of this part by using the product rule, which is eventually x times dy over dt plus dx over dt times y by using the product rule. And now since we would like to find out the rate of change of area when x is 24, rate of change of x is 7, the y is 7, and the rate of change of y with respect to time is negative 24. So we are going to plug all this value back here, and after doing the simplification, it will be negative 527 over 2 feet square per second. Again, the area is changing, area is decreasing. As the height decreases, the area decreases. That's why the rate of change of area is negative here. Finally, we would like to find out the change in angle theta. So for that, we need to find out the relation of relation of theta and then x and y variable here. Okay, so by looking this picture, we can see that sin theta is, opposite side over hypotenuse, which is y over 25. So if we differentiate both sides with respect to time, on the left side we get cosine theta times d theta over dt. On the right side, it's a 1 over 25 dy over dt. So for finding the rate of change of theta with respect to time, we need to find out cosine theta when we have x equal 24, dx over dt is equal to 7, y equals 7, and using this picture, this graph, we can find out the cosine theta, which is basically base over hypotenuse, which is x over 25. And since we know x is 24, so that is 24 over 25, we're going to plug this value of cosine theta in the given equation here. So 24 over 25, there is already 1 over 25 times negative 24. So we can cancel this 24 on the left and right side. We can cancel this 25 and 25 on the left and right side. The only remaining thing would be negative 1 on the right side. So the rate of change of theta with respect to time is negative because theta is also going down. And that is the unit for a rate of change of theta, which is radian per second. Okay. The very last question here, the radius of a circle is increased from 5 to 5.03 meter. Estimate the resulting change in area. Express the estimate as a percentage of the circle original area. So first of all, we have to understand that for a circle, we know the formula area equal pi times r square, and then radius of circle is changing from 5 to 5.03. So actually the circle itself is getting bigger. Okay, and here we can see that change in the radius, this is the notation we use, dr stands for very small change in radius, is 0.03. So we would like to find out the change in area, so just say differentiate dA equal derivative of r square is 2r times dr. So to find the change in area, this is the differential. We just have to plug the value of r, which is 5, and the change in r, which is 0.03, and just simplify them, and our answer would be in terms of pi, which is 0.3 pi. Since this is a change in area, so it would be meter square. So the answer for this one is 0.3 pi meter square. And based on this change in area, we would like to change percentage in area. and that can be done by just dividing the change by the actual area, so which is 0.3 pi by 25 pi, which we can calculate by using this formula. So the area is pi r squared, pi times, when the radius is 5, so the area would be 25 pi. So 25 pi is the original area of this radius, this circle. And since this is a change in this area, so actually the net change is 1.2%. Okay, so that's the last question.